Vector databases or vector search in general has become a buzzword lately, especially with the rise of LLMs and RAGs. But the real question here becomes, is it really here to stay? Does it really have a business value? Stick with me for the next 5 minutes and let's find out. Let's assume we are building a solution for the search of titles of blogs. And those titles are going to be the followings. So let's take 3 titles, for example, that are going to talk about the best player in the world. The first one is saying that Messi is the best player of the century. The second one is saying that Mbappe is the best player since 2018. And the third one stating that Ronaldo or CR7 was never the best player in the world. The common thing between those titles is that they mention the word best, they mention the word player. The third one mentions, in addition to this, the word football. But the third title has a negative sense because it states that CR7 was never the best player in the world. But to spice things up, let's add another fourth title that is going to say Pele was the GOAT in soccer. So here we replace football with soccer, and then we use the word GOAT. So if I'm asking the question who is the best player of all time, I am supposed to get the fourth title. But let's not go there yet. Let's, for example, build a solution, a search solution. So the first thing we need to do is we need to choose a search engine or a database that is going to support the indexing. So for this example, we're going to choose either Elasticsearch or OpenSearch. And then we're going to go ahead and we are going to index our titles. Indexing means that we're going to take those titles, we're going to split them into keywords, and then we're going to calculate or compute the occurrences of those keywords in the titles. So here, for example, you can see that the word the is mentioned in all of the titles, best is mentioned in the first 3 titles, etc. So once we index all of those titles, then when a user comes in and interacts with our database and asks the best football player of all time, then what's going to happen is our search engine is going to the title that has in its database, it will get the result and it will rank them. So the first mechanism of ranking is the term frequency. So basically what's going to happen is the title that has most of the words and with the maximum of occurrences will get returned. And since here we have the word football, the word player, and then the word best, there is a high chance that we're getting the title CR7 as the first article here, which is not what we're looking for. So the term frequency was not the optimal solution here. And there was a lot of ameliorations for this algorithm. We added something that is called inverse document frequency. Basically what we are saying is you get the frequency of the words, but if the word gets mentioned a lot in the documents, you need to ignore it because it's everywhere. But this still does not answer our question, does not solve our problem because we are never going to get the fourth title, and there is a high chance that we are going to get the third title. So there was another amelioration, which is the BM25. So the BM25 is something that ameliorates the TF-IDF basically by taking into consideration the length of the document, etc. But as you may notice here, we are always mechanical. We are always just switching the metrics around. We are not getting the sense of the word, etc. So we are never going to get the fourth title, and there is always a high chance that we're going to get Ronaldo as the best player in the world. So in order to solve this, we need something that is more human, something that would extract emotions from text. And the solution that we found is something that is called embedding model. So this embedding model, when it takes a text in, it will try to extract not only the keywords, but also the emotions or the senses that are in the text. But the way it extracts this is it converts your text or your input into a mathematical representation, which is a vector of numbers. And in order for you to store this, you need to have something that is called a vector database. That's why those 2 solutions, for example, Elasticsearch and OpenSearch, they opted for an additional feature that is a vector database that is going to be able to compute, not to compute, but to store those values. So now the thing that we need to do is we can just take all the values or the titles that we have in here, we're going to make them go through the embedding model. We're going to extract the sense from them. So for example, this time we're going to know that the title 3 is negative, we're going to ignore it, and the title 4, it mentions GOAT, so we're going to know it's in the term of greatness, for example, in the sense of greatness, which is a human feeling, then this is the best that is going to rank the best. And we're going to extract the mathematical representation of this, and then we're going to store them in the vector database. So now when our users ask the question, the best player of all time, what's going to happen is we're not going to send this query directly to our search engine. We're going to go ahead and extract the meaning of this question using the embedding model, and then we're going to extract the mathematical value out of this, and then we're going to compare it to all the other senses, all the other vectors that are in our databases. And by doing so, we solve all the problems that we had, and now we are going to be able to get Pili as the best player of the world. So that was how the vector databases work and what they need in order to work. The next question that comes into our mind is, how is the performance of those databases? How is it computed? But this is another talk for another 5 minutes.